Now to talk to us about what to do when you have actually too much data, how to deal with it. So,
thanks, Dragos. Yeah, so what I'm going to talk about today is basically some best practices and considerations. I used to retitle this do's and don'ts, but I think it's more considerations and things that you need to think about when you're doing, not just with big data, but when you're actually doing a data science project. So a data science exercise, what are the things that you need to think of? And so that's what I'm going to give you my perspective. I have 30 minutes, right? Yeah. Usually I give a 2-day course to, I've done this in Canada, plus I do it overseas, where I give a 2-day intensive course on predictive analytics and data science. I've also teach at George Brown and Seneca, so I'm an old guy when it comes to data science and data mining, so I have a lot of years of experience and practice. I think there are a lot of you in the audience, probably most of you in the audience, that have much stronger math skills, just listening to our last speaker, than I do. But where I come at it is I apply the math. So at the end of the day, it's like, how many of you seen that Tom Cruise movie? The one there about where he plays the agent? Show me the money. That's what I'm about, is if we're going to use techniques and algorithms, at the end of the day, is it like for a company, is it making money? If it's a not-for-profit, is it achieving that incremental metric and all that? So that's really where my philosophy when I'm doing data mining and data science is like, am I delivering incremental value to the business or unit that I'm working on? So I gotta use it. Okay. I'm a tech guy, eh? Oh, there we go. So basically, in building analytics solutions, we have this 4-step process. Most of you may be familiar with this, or if you've been reading data science or data mining textbooks. This process is basically problem identification. What is it you're trying to solve, and then the data. So creating the analytical file of that data environment. And then the third area is the data mining tools. Like what kind of, are we building a model, or are we creating reports? And in the third stage, this is where we would be employing maybe some artificial intelligence or that kind of technology. Now, I don't know how many of you are jaded by all the talk about AI. I know I am, because I hear a lot of people, in my opinion, misuse it in terms of like what artificial intelligence is, or they say it's just basically the machine. So in some circles, artificial intelligence could just be creating an RFM type model, which is like, RFM is basically how often did, when was the last time you did something, how often do you do it, and then the amount. Basically, you can create a program, whether you're using Python or R, to do that. The machine is doing that, not the human, because you're doing that against 100,000 records. You could have, techniques. You take it up a notch, where you have techniques like multiple regression or logistic regression, where it's getting a little bit more advanced because there's iterations going on. The mathematics being employed is where you're looking at all kinds of iterations and feedback, although that feedback is being optimized against a known, or against what the expected distribution would be. For logistic, it would be sigmoid. For multiple regression, it would be linear. And then you take it to the next step, where you have neural nets, which, in my opinion, this is where you get into the deep learning. And as I said, when I read one definition was, it would seem to be that a lot of the common definitions is it's embracing all of these traditional type of techniques. And somebody asks me, when I look at artificial intelligence, I'm looking at it the way it's being described here, which is the deep learning. The fourth area is implementation and tracking, which means how are we going to deploy what we build, and more importantly, how are we going to measure it. So if you're doing something in AI or some kind of advanced technique, I would urge all of you to be able to demonstrate that number one, it's working, and then if you can, compare it to what's traditionally been done. Okay, that's typically if I'm, and I don't have a slide here, but in our shop, we develop all kinds of models for many different clients. And we use a lot of the traditional techniques. Why? Because they're easily explainable. So if you're trying to explain a neural net to a business person where you have, let's say, 3 or 4 hidden layers, how do you explain what are the key inputs? And I think there's a lot of research being done in that area. And right now, the explainability of neural nets is a challenge. So a lot of data scientists are deferring to the more traditional type of techniques because of explainability. Nevertheless, recognizing the power of neural nets, what I do is I get all the models that are built. I always ask them 2 things: give me the algorithm, the data set, and your code. What I then do is I take that code and then I start to apply some neural nets. Basically, I'm using SAS. That's the language that I have, that I'm familiar with, and I'm applying the neural net technology within that to see if I'm getting any incremental lift. So let's to go through each of these 4 stages. The number one thing is identifying the real business problem. Let's define what the problem is. So again, if a good example is I might be asked to build a retention model. So what's the likelihood of somebody staying with me or the likelihood of somebody canceling? Right? You say, okay, well, I'm going to go build that. But then you have to define what cancellation is. So is cancel, and that's going to vary from business to business. Like if I'm a grocer, arguably defection could be somebody that doesn't go back or go food shopping in the next week. If I'm trying to purchase tires, defection could be maybe 1 or 2 years, or even a car. So again, you have to, and how do we go about defining that problem? Well, I don't want to get, instead of limited by time, but there's analytics that's done to define what retention exactly is. I'll give you another example. When I built my first model many years ago, I was working at American Express. I built a response model. So these are people, this is built to optimize the likelihood of somebody applying for a credit card. I was a much younger guy, so I built the model, worked, and all the marketers were very happy. I got all kinds of, I got great lift. And so it worked very well. But 2 weeks later, I got a call from, the credit risk area saying that all of a sudden, or saying, we're having a lot of these applications coming in that are being declined. What I had done, this is many years ago, is I built a model to optimize the likelihood of somebody applying, not necessarily somebody that would be approved. So again, these are just basic things in terms of what we're trying to do in terms of defining the problem. Looking for quick wins. So if you're looking for a quick win, one of the things that we do, and Nassim, I was talking with her before she gave her presentation, we're really trying to identify that low-hanging fruit. So where can I make the biggest bang for the buck? So I'm coming in, I'm going to look for areas. So if I'm in an organization, I'm going to look for areas where there hasn't been much data science that's been done. And I probably don't even need to do something too sophisticated to achieve a good business result. But that's what I would be doing, is if I'm going into an organization, is identifying areas that can really, where I can really sort of pick off that low-hanging fruit where I can make a difference. Another way of, and again, once you're creating that quick win, how do we demonstrate that? So here's a retention model that we built. So this is, for any of you that are new to organizations, if retention models are not, have not been built, that's probably a good area to start. and one where you could demonstrate payback. Here, we have, what we're trying to demonstrate here is the savings without a model and the savings with the model. So what we're demonstrating here is the ability of the model to really identify more people that are going to defect. And so we can take that metric and then say, okay, what's the dollar value of those people that would defect versus the people that we can identify without the model. So we're going to identify more people with the model, but then what we're doing is we're saying, okay, we're assuming that the save rate over here is the same. Now that's an assumption, and basically we would evaluate that probably 6 months or 6 months down the road once we did a campaign. But you can see here that, assuming even with a constant save rate and an average value of $300 per customer, we can quickly demonstrate the value of what the retention model can do. Now again, this is like just up front. What you'd want to do is evaluate whether, what indeed that save rate would be. Whether it is 20% or some other metric. Okay. Number 3, become familiar with the data. So again, what data do we have? How do I create variables that are going to be valuable in the analysis that I'm going to be doing? And again, I want to complete some preliminary analysis to help me get that familiarity. And so some of the things that we do is we look at metadata, which is basically looking at the number of missing values, the number of unique values, means, mids, maxes, frequency distributions, and then also what we'll do is a random data dump. So we're doing an exhaustive data audit to get familiar with the data. And on the next slide is an example of that. This is one of our standard data audit reports, whereby here we're looking at each field on each file within the data, and what we're trying to understand is the number of unique values and the number of missing values. So obviously, if we have a lot of missing values, those specific types of variables are not going to be useful in a data science exercise. But again, I'm just showing you one report. This is an example of one report where we're trying to understand the data and understand what's being useful. The other reports, which I'm not showing you, are frequency distributions, as well as sort of a random data dump to really help us understand the data that we're working with and how we might group that into an analytical file. And the other thing I'm not showing you is the arithmetic diagnostics. So for each variable, what's the min, max, averages, and that sort of thing. So statistics. What are some key tools that the data scientists or that I've used in the course of my history? One is correlation analysis. That's typically in a data science exercise. I call that the first statistical glimpse of the data. So if I'm building a retention model and I have 200 variables or 300 variables, which variables most impact defection? And I'm looking at that. I'm looking at those 200 variables and looking at that. And really ranking them in terms of which variable most impacts defection or retention. I will also use CHAID, which is a decision tree type of tool, which most of you are familiar with. But I will use CHAID or decision trees to actually help me create more variables. So I might use it in a modeling exercise, but I will also use it to create further variables where I can group a lot of these types of variables together. Factor analysis is a great tool in terms of data reduction. So how can I take 300-400 variables and maybe group them into, let's say, 100 variables or into other patterns? Now, I will use factor analysis not necessarily to reduce. I like to work with lots of data, but actually to find patterns where I might actually create more variables from the factor analysis. Cluster analysis is again is a technique that we would be using in segmentation. So marketers love this type of tool. because it allows the business to understand if I have 100,000 customers, how do I group them into perhaps 5 or 6 different segments. And if I'm able to do that, I can actually create personas around those different segments and ultimately communicate with them or communicate differently to each of these segments. So clustering is a very, very popular tool for most organizations. I know that the story I use, I remember Royal Bank, it was a while, many, many years ago, did a clustering exercise where they had 100 segments off their customer base. And the question is, or the challenge or the conundrum they ran into was, what are they going to do with those 100 segments, right? So it's great that you have come up with 100 segments, but are you going to action it, right? So that's what you need to think of when you're doing this analysis, is how you're going to action or deploy it. This, again, is another representation or example of key output that we do to demonstrate a given model. This is called a decile chart. How many of you are familiar with decile charts? None of you. Okay. So let me walk you through what this is, because this is for people that are in customer analytics, whether you're building risk models or marketing models. This is what the business is going to look at. They don't give a damn. They don't give a damn about your predicted versus your action. They could care less about that. That you might, we as data scientists might care about that. And typically, if you were able to show that your predicted is close to your actual, you will actually get a better rank ordering or a better decile chart here. So what this chart does is this is a validation sample. So I build a model. I build a model off one set of names, and I take that algorithm or that solution from one set of names, and I apply it to a first set of names. So a holdout group, which you're all familiar with if you're using AI techniques. So this is the same concept. In this case, I use a logistic regression. I take that validation, and then I simply rank it into 10 deciles. So this is my top predicted scores versus my lowest predicted scores. And this basically represents what actually happened, we observed. So if I have a good model, in theory, I should get better rank ordering. So if I have a crappy model, basically this number becomes flat. Okay? So we take these decile charts and we actually, once we understand the economics of the model that we're building, we can actually start to translate that into ROI. Because we understand like how much a responder will generate in terms of value. We understand the cost, how much it's costing to promote that customer. So we blend in, like in these charts, we will blend in all those metrics in along with the model. Now that may be, what I might do is I might actually build the model and then give them the scores and the response rates. The business people might actually generate more of this stuff because they have that kind of information. But as you can see, it's very useful because now I have a model and right away it's telling me I should cut off or I should select only the top 40%. Because clearly once I start promoting the bottom 60%, I'm losing money based on this particular campaign. So this is why I'm giving you a little history of why data science is so popular. Like I've been building models for 25 or 30 years. We did this for a bank back in the mid-90s where they didn't have a data science team. And we were able to demonstrate this kind of payback, and all of a sudden data science, they recognize that data science has to become a core competency because of the huge benefit and dollar value that these tools can bring. And now with some of the advancements in AI, which I'll talk about later, we can now further accelerate the type of benefit that these things give. Again, has less applicability with artificial intelligence, but with some of the more traditional techniques. How many of you are familiar with multicollinearity? So a few of you. So if you're using like traditional regression types of techniques, you have to be careful. So you might have, in this particular example that I'm showing you, you have, and I just kept it very simple, you have two variables. You have income and education. You can see that when I do the correlation is looking at how these two variables correlate against response, but in a univariate way. So just against the target variable and against the objective function. When you bring it into a regression, now all of a sudden you're looking at it in a multivariate type of way. This is where you get multicollinearity, where variables can change sign. So in this case, you can see that the years of education change sign. Yet in correlation, you actually see, and if I could show you other reports, you can actually see that the relationship between education and response is positive. So the more years that the longer I've been educated, the more likely I am to respond. The multiple regression is telling me something opposite to that. Now, a lot of purists or mathematicians will say, well, that's the reality of the math. I am a practitioner and I know that there's lots of noise in the data, so I'm hesitant to use something like this where I see signs flipping. What I will try to do is I will do some further work to maybe perhaps combine this variable and these variables together. So I would do some shade to try and look at that, how I might combine that. Or I would start to look at other variables. But again, trying to keep the performance of the model at the same level. So again, that's always the objective, is to try and keep the same performance level of the model. But for sure, I would not present that as my final algorithm. Quickly go through this. This again is a classic case of using art and science. This is a case where a retailer collected no information, and the only information we had was related to market research. So again, we couldn't use the market research information because market research is typically only applied against a small sample, right? So and again, this is where the creativity of the data scientist says, okay, well, can I apply this learning based on data that I know or that I have? And what we do have, how many are familiar with StatsCan data? We have, yeah, a number of you. We have StatsCan data. My company, Environics Analytics, takes the StatsCan data and creates a lot more data on steroids, so to speak. So we have a lot of this demographic or external type of data which we can use. So what I did here is I took the learning from the market research, income, female, and percent landed immigrant, and I had that information from StatsCan at a postal code level. And I start to create index variables. So I go in against the Canadian population and take averages. What's the average income in a postal code? 1.25, 1.15, and 2. For a specific postal code, what is that value? And I just simply start to create indexes, as you can see here. And I weight them equally. Now, I might talk with the business team and they may say, oh, well, we'd like you to weight income at 50%. So that's a situation, or that would be a discussion with the business team to see how they might want to weight this. And then again, what I have is I would take those indexes, and now I have a way to rank all those postal codes or those zip codes from top to bottom using the index. And I now have a way to at least go out and to test my my solution. But at least we've gone from doing nothing to doing something, using basic data and using some art to come up with a way to rank postal codes. So, you know, we could say, okay, customers that are in the top 15%, let's go in and market to those customers, and for now, let's just negate going into the bottom 85%. Okay, implement solutions carefully. This is I'll try and explain this chart. This is a live example. This is a risk model that I built, a property risk model I built a number of years ago. And what I wanted to show you is when we implemented this model, I got horrible results. And it puzzled me, because it always bothers me when I get bad results in a model. I'm kind of obsessive in that by my nature. So I go in and go, okay, what is it? What variable did I use? Did I do something wrong? So I'm really, I guess my obsessive nature kind of helps me in the data science world because you have to be detailed. So I went in and I started taking a look at, these are some key variables that are in the model. I don't want to show you all the variables, but you can see that there are differences here. Like in the model, I had replacement costs, I had this kind of a chart versus on implementation, it's much flatter. Take a look at the age of the property. The age of the property, the model, you can see is much, sort of decreasing in a downward way, saying as the age of the property increases, the likelihood of loss decreases, right? You can see that there's a trend going down. Look at this blue line, flat. So I was looking at key variables and going, there's something wrong here. I went back to the client and I said, can you give me your, how did you pull the data? Oh, I can't give you that. I said, can't you even give me your code so I could find out how you pulled the data? Oh, we can't do that. I found out through the back end that what happened was when they went in and did some digging, what they gave us, or what we had, is when we built the model, we built the model on residences. In other words, no apartments. But when we got the file for implementation, which is this, we got everything. We got residences and apartments. So again, I think you're seeing a lot of nodding heads. You can see that when you're dealing with two different types of data sets, you've got very different results. And of course, the model should not expect to work when you have maximum. Most of the file, if I remember, contained apartments. And we built the model just off houses only. The next thing I want to show you is measuring and tracking results. What we did here is we built a series of models. I know I'm kind of coming up on my time. I don't want to leave time for questions. What we're trying to illustrate here, this is with a gaming company where we built a series of migration models. And what we were trying to demonstrate is the accuracy. So how well did we predict and what actually happened? And if I point you to here, you can see here that in each of these migration models, we're off by between 0 and 10%. But again, we measured what we did a year later in terms of how we migrated customers. Okay, so I kind of want to talk a little bit more about what's going on more recently and how that impacts me. I've been at this a long time, and there's no question there's been big changes. We all know certainly I know in the last 5 or 10 years, big data. We're seeing increased automation of tools, and of course we're seeing artificial intelligence. So big data, what is new? Okay, give you a perspective. Back in the old days, prior to big data, when I was doing data mining or data science exercises, what I would do is I would ask the clients, give me everything. You can no longer do that now. We have, how many of you are familiar with data lakes? Yeah, now we have so-called data lakes where there's so much data that the data scientists and actually the business person need to be involved in terms of what data do we actually need to solve a given business problem. So in this case, it's requiring a lot of newer types of ETL skills, like as I'm understanding it, like Java type skills. Java programming is being used a lot to try and extract this data. Python, these types of tools going in to be able to extract and scrape the data that we need. The data scientist needs to be able to work with back in the old, historically most of the data was structured. But because of technology, we now, as you all know, we have a lot more semi-structured, unstructured, particularly with social media, IoT. We have a lot more of these types of data that's available. And so we need newer tools to work with that. Increased demand for text mining. So along with unstructured data, how do we work that data? So how do we work with unstructured data to come up with meaningful variables. And I guess how many of you are familiar with text mining? Okay, most of you. Okay, so I'm often asked what text mining is, and I go back to the Donald Rumsfeld phrase. It's kind of like I don't know what I don't know. So you're using, when you're using the old search engine type of mentality in search engine technology, you're actually putting in a particular thing that you're searching for, and then you get a list of items. With text mining, you don't know what you're looking for. You're using the unstructured data to help you come up with themes and topics that you can then do further analysis. So if we have a body of emails or a bunch of social media posts, I would go in and analyze those posts and try to come up with themes or topics that I may use in a particular model. The last point is increased data governance. And so we're all familiar with what's happened in the last couple of weeks with Facebook and Cambridge. So I think we as data scientists need to be very, very cognizant of these issues and how we're using the data, and very respectful. Marketers who've been in the analytics game for a long time are very, very familiar with this, because the last thing you want are customers being angry about how you're using their data. And so governance is not a new thing. It's just become more emphasized because of social media and because of the tech companies that are now taking what we used to do in direct marketing and now put that on steroids, so to speak. So this is an example of, I talked about increasing automation. This is how many of you are familiar with Alteryx? Okay, so for those of you that aren't, Alteryx is a great tool for what I would call the citizen data scientist, because you don't need to know how to code or how to program in terms of processing data. What you do need to know is you need to know how to work the data. So I take raw data at the beginning, how do I work through that data to create an analytical file? So here I have, this is sort of the beginning stage where I'm actually loading in and reading the data, and then here at the end is my actual output, which could be a report. So analysts, or I call them citizen data scientists because they're actually plowing through the data, are using this type of tool to create an analytical file. Might take their output, and then we would take that into, let's say, R, Python, or SAS, and develop models off that. Okay? How many are familiar with a tool called Data Robot? No, there's one. You are, yeah, you're World Bank. Yeah, so Data Robot is kind of like, I would call a sort of factory modeling type tool, whereby you have an input file or an analytical file, and you can generate like many models in a matter of minutes. And what it demonstrates back to the data scientist is which one is the best, which one is the best model, which one is delivering the most lift. And so this tool is a relatively new tool. It's been in existence for 2 or 3 years. SAS has also what they call their factory model tool, which kind of does the same thing, which is like really what I call modeling on steroids. Again, tools. Doesn't take away from what the data scientist needs to do in terms of where it's going, and I'll talk about that in the last slide. So what about AI? So I'll talk about AI from my perspective. I was, as a data scientist for a long time, AI is not really new. They were doing a lot of this stuff, like image recognition, back in the 90s. And I remember I used to get these black books from, how many of you are familiar with Katie Nuggets? Yeah, a number of you are from, okay. So I used to get these black books on Katie Nuggets, and there was a lot of work, I think being done by Jeffrey Hinton from the U of T, that were trying to break through that image recognition. And they were getting 50 or 60% back in those days, right? Last 5 years, boom, they went to 95%. And that breakthrough was the reason why, You know, we're seeing all the talk about AI. Well, you know, you get The Economist, it's the front page of The Economist, AI, spy, or whatever. So, you know, we're seeing that the tremendous improved accuracy of AI and the breakthroughs they made on image recognition 5 to 7 years ago, we're seeing a lot of other applications that we now need to look at that. And the two big things that have lent themselves to that, and I think Zim talked about earlier, is one, we have a lot more data, right? Big data, a lot more data, and we have the computing power. We now have the computing power through big data to do, math produce, to process all this data. So those are the two big things. Lots of data and basically computer processing type technology. And so we're now able to take, you know, what maybe in the old days where I had a simple neural network, we're now able to look at multiple hidden layers. And I've just used 3 or 4. In some cases, it could be well over 100, depending on the application. I've done work where I'm looking at it from a marketing standpoint, and I will play with neural nets. I will play with the optimization algorithm, but I will actually toy around more with the hidden layers and the number of nodes. So I will look at maybe trying something with 3. I usually have about 8 or 9 different permutations. Like I'll try something with 3 and 3, 3 hidden layers, 3 nodes, 5 and 3, 5 hidden layers, 3 nodes, maybe 5 and 5, 10 and 10. And I keep trying until, am I getting a better and better solution? And then it starts to level off, right? And so I'm playing with this to try and see, am I getting better? In a lot of cases, I don't. The traditional techniques work quite well. Some cases they do. Like today I was looking at something where I had a little bit more data, and I did see some incremental improvement in terms of what the traditional techniques that were being used. And the traditional techniques were presented to the client. I was actually able to see that, oh, we are starting to see some incrementality. But how would I explain that to the client? I don't know, just trust the neural net. That's not going to fly when you're talking with the client. But again, I think we as a community need to think about that. The explainability is without a doubt the largest issue in the business community for artificial intelligence, especially in marketing and risk. You know, in a lot of other applications, people don't care. So in healthcare, they may not really care because it's a different application. But in my world of marketing and consumer analytics, they do care. So this is the last slide. So where do I see things going? Where I see things going is that I'm looking at the data scientists, let's say 5 or 10 years out. Right now, a lot of us know how to code. I'm an old guy coding SAS. I know a little bit of R, a little bit of Python. You know, Nassim, right? Yeah, Nassim is Python programmer extraordinaire. So all of us have our languages that we use to code. I do as well. I wouldn't be where I am if I couldn't program. Right? I have to be able to code. But a lot of these tools are going to get better and better. AI, I expect there's going to be lots of vendors. We're seeing that. We're seeing that with Data Robot, where they're producing better and better tools. So the data scientists will evolve. And there's going to be tremendous demand for those individuals that can identify a problem, identify a challenge. The data scientists, not the business people. Because the data scientist needs to have that understanding, but also the understanding of the data. This is our strength. We understand the data. And how to align the data to address the business problem. This is what we bring to the table. And so the citizen data scientist will then have tools to help us solve that problem. But the citizen data scientist will still need to understand how to process the data, how to work the data. So it's not just I'm going to push a button and magically an analytical file is going to appear. No, I have raw data. How do I work and what kind of data do I need? So what kind of data do I need? How do I work the data so that I have a meaningful analytical file so that I can apply whatever technique I need, whether it's a neural net, maybe a logistic regression, or even a decision tree. Maybe look at all 3. And so this is where our knowledge is going to be used, but it's going to be less. You're going to see a huge demand for people in the citizen data science need to know how to program as much, but they will need to understand how to solve problems and how to work with data, because technology is moving in that way that a lot of these things are becoming automated. Even in creating the analytical file, there are vendors out there that are saying, you know what, I was just emailing somebody just before I spoke here that gave me, you should check this tool out. It's called H2O. It's a vendor in the States. They profess to do what they call automated machine learning, where they create variables on the fly. I have my skepticism because I've been at this for so long, but again, maybe some of you think I'm a Luddite. I'm not. I'm always embrace what is new and what's out there to see, you know, like how do we move the discipline forward. So again, and if all you have to do is take any of the reports like Forrester or Gartner to see that you're going to see a huge demand for these citizen data scientists in 5 or 10 years out. So for those of you that are coders, great. Those skills are always going to be in demand. But there's going to be a huge demand for these citizen data scientists. So I would say, spend time trying to understand businesses and domain areas, and also data. How do you line up the data? Because that, to me, is where the future is. No algorithm is going to automate that. So that's all I have to say about that.